Good morning.
Morning.
Thank you.
Morning.
Good morning.
Welcome to Monday morning.
Good
We
night.
we never thought it would arrive, but here it is. Hope you had a good weekend. Today we're doing Unreal coding. What? Really? Yes. You thought we'd peaked last week, but you haven't seen nothing. So let's just get back to kind of what we were doing, because I don't remember. And then we'll figure out what to do today. Could be anything.
Think we made ready so we can do actual power-ups. We did
That does
Yeah.
sound familiar, yeah.
We did the randomization. Like now we have an array of race power-ups.
Okay.
Where when we pick up a power-up, we kind of pick up a random power-up out of two.
I mean, I was kind of joking when I said I don't remember, but thank you.
Oh, what? Well, that says a lot about my belief in you.
Yeah, don't you look
No.
stupid now, too?
Just- We're having a recap.
Yeah, I was doing a little recap for
It's
the
for the
YouTube.
subscribers, I mean.
Yeah,
Yeah.
exactly, for the subscribers, because it's been a while since my last upload. Yeah, so we have like power-ups now. We have two testing power-ups. So I can hit space and then it says test power-up. And then here I got the poo-poo power-up. So it's randomized whenever we grab one of these Mario Kart thingies, pickups. So that's nice. That's cool. That's neat. But let's actually make it so the power-ups do something, because that would be fun. Instead of just being boring.
Let's fix the steering when you're backing up.
Oh yeah,
First.
let's do that. Yes, thank you. Let's fix the steering, huh? I have to think about this. Because when I turn... Oh, I know what it is. I know. You know. We know. I'm gonna go into car movement component. Yeah, okay. So the thing is that with steering, alright, so the way steering works, it's quite complicated, but I'll go through it. Just coffee sip to get ready. So the way steering works is that your wheels are pointing to the side, right? That's very sharp turning angle, but bear with me. And then for every unit traveled forward, like these wheels go down a little bit. And that's how your car fucking turns. Now, we did a simplified version of this, just taking the size of the velocity. But let me ask you this. Bro, if we go sideways, we're not supposed to turn, are we? Maybe a little bit. Let's say we don't. I realized when I asked the question, actually we will turn a little bit, but let's just say we won't. Okay, so we won't turn if we go sideways. That's not fair. And of course, if we go backwards, the wheels will roll in the other direction, making us turn the opposite way. So clearly, just taking the size doesn't do enough for us. We need to figure out something else. Really, what we want to figure out is how many units do we move forwards? And that includes positive and negative. So if we go backwards, we want to have, okay, we're traveling actually a negative amount of distance forwards. Because then we get this behavior where if we turn one way when going forwards and the other way when going backwards. So instead of taking velocity size, I'm actually going to do a dot product here. So I'm going to do velocity dot product. Get actor forward vector. So now we solve both those problems. Cuke. Yep. Then we solve both the then we solve both those problems. Whoops, it's supposed to be owner. That we won't turn when we go sideways, because then the dot product will be 0. And we'll turn positively when we go forward and negatively when we go backwards. Just like a real car. Just like a real car. Exactly like a real car. Like a real car. Like in real life. So let's try this.
But don't you need 2 vectors?
Cook. Yes, you're right. No, this is supposed to work. Oh yeah, sorry, this is English script. Sorry, this doesn't work like this. There we go. It's a static function. I think they have... I think they've... Like, don't do this. Oh. Don't do this, but I think they have actually overloaded the hat operator. So I think you can do this. Velocity... Whoops. Velocity... Hat... Owner... Get actor forward vector. Yeah, it doesn't really want to format, but I think this will be the dot product actually, if I remember correctly. But don't do this. This is I will not understand what you mean by this. So we're just gonna skip that. But let's see now. So if I go forward and I hold right, I turn right, and if I hold backwards, it works. So now it works. I think. It feels correct. Alright, cool. So that was the fix. Easy. Alright. Man, we're just squishing these features like it's nothing. So, yeah, so let's make the power-ups do something cool instead of doing something boring. So, what's a good power-up? Boost? I guess boost is a fun power-up, so let's do that. So I'm actually gonna make that in C++. So we're gonna make this in C++. So paint? What are you doing hiding back there? You go away. So we're gonna make a new power-up. Actually, I'll go into here. FG Racing Game, source, power-up. I'm gonna make race boost power-up.h. And race boost power-up.cpp. Whoops. Yep. So this will be our boosting power. It will be like the mushroom in the game, in the other game. We're not copying, by the way. We're making our own game. It's just very similar. Don't sue me, please, Nintendo. Can Nintendo sue that I'm teaching to make Mario Kart? Can they sue that?
I don't know. Let's find out.
I feel like they can't sue that. That doesn't make any sense. All right. So I'm gonna pragma my once. I'm gonna include raise power up. I'm gonna include raised boost power up generated H. Gonna U class this. And then let's make it. Raise, oh whoops, you raise boost power up. Public you raise power up. Generated body. All right. Okay. So, we run into a problem now. Because when we activate this, I want to give some sort of boost to the movement. However, to do that, I need to override. I need to override this, right? This on power up activated. But I can't. Because it's blueprint implementable event. Blueprint implementable event means that this is supposed to be implemented in Blueprint as an event, and it cannot be implemented in C++. Sad face. So, I'm gonna change this to something called a Blueprint native event. And a Blueprint native event works more like a traditional virtual function. Meaning that we can override this in C++ like a virtual function. So we can have multiple implementations there, or override in Blueprint. So it's not just override in Blueprint, it's also in C++.
What happens if you do both?
Then it will call the blueprint first, but then you can call super on that blueprint. So from blueprint you call super, and that will call the C++. And the way that this works, it is kind of ugly, kind of fugly. But the way that this works is that you don't... I don't quite remember. I haven't used native events like 5 times in my life. Let's just see what happens. I'm just gonna compile. We should get a linking error here. Ten actions. Yes, cool. Let's see. Yeah. Okay. Yeah. So the problem is that, so the thing is that we don't implement this function. This function still stays unimplemented. It will be implemented by the generated code from Unreal. So Unreal will implement this one. Rather, if we want to override from this, we implement... I'm going to the CPP file here, by the way. I'll put this here. We override on power up activated implementation. I think. Wait, hold on. Let me double check. Yes. On power up activated implementation. This is the function that's actually called when we call on power up activated. The reason we can't just override this function is that this function will be implemented in Unreal, like the generated code, to kind of check like, okay, is it overridden in Blueprint? Okay, then call Blueprint. If it isn't overridden in Blueprint, okay, then call the CPP version. So that code needs to run first to actually figure out, should it call the BP version or should it call the C++ version? So that's why we can't actually override that function, because it needs to do a bunch of shit. And that's why we have this other function called onPowerUpActivated_implementation that is actually the function in C++ that will be called. Kind of ugly, but it is what it is. Of course, the upside of this would be if we want to call this function and have it work like we kind of expect it to, we can just call it like this. Like we can just call it like a normal function. And it will just work. It will either call the Blueprint version or the C++ version, depending on like how that's implemented. Whereas if we didn't have this setup where on power up activated actually does the check like, oh, should I call Blueprint or not? Then we'd have to do some weird shit to actually, insert that code somewhere. So it's kind of a necessary evil, unfortunately. But yeah, so if you do a native event, you have to remember to not implement the actual function. You have to implement this underscore implementation version.
So, actually, never mind.
Okay. Thanks. So the same thing goes for a bunch of other U functions. Later when you're gonna talk about like networking stuff, it looks very similar where you define a U function as like an RPC or something, and then the actual code lives in this underscore implementation. Okay. So now that we have a Blueprint native event, we can actually override this in our power-up, in our boost power-up. And we do that by doing like this. So we'll do void on power-up, activated implementation override. So again, we don't override the actual U function like this one. We don't override this one. Rather, we override the implementation part, the thing that actually runs in CPP, if need be. So this is the one that we override. So now we can do stuff in the CPP file. So let's do that in the raised boost power up CPP file. Am I going too fast? I feel like I'm going quite fast. Should I slow down?
It's cool.
It's cool. All right. So I'll implement this in the CPP file. In the boost power up, that is. So we're in the boost now. So now we should have stuff happening here. And to double check before we start spending a bunch of time on that, let's just sanity check that what's happening is actually what we hope is happening. So I'm just gonna log here. Actually, let's print the screen. Let's go to the G engine. Add on screen debug message. Key. Index none. Time to display 5. Color. F color. Red. Is there any fun colors near? Oh, there's a bunch. Oh, purple. Let's go. Fucking get some Afton up in here. And then we'll do... we'll print... From C++, what? And that will be good. So I'll just call this. And let's see if it's gosh darn works.
Hello?
Hello?
Okay, good. I was muted. Thank you, Ruta. Do we have to have the on power-up activated implementation in the raise power-up.cpp as well?
Yes. So the base version will just do nothing.
Oh, rude, Thomas. You didn't ask if you could ask a question.
Yeah, what if I said no this time? Wouldn't that be awkward? If we're like, please, not now, Thomas. I'm compiling. I'm busy.
I'm going to ask that next time.
No, please don't. You did so good.
You better.
You did so good. All right, so now I'm gonna
Can we-
add this. I'll go to the power up pickup. I'm just gonna add this to the list. So we'll also, so now you can see that this raise boost power up also shows up in this list. So I'm just gonna add that there. So now this also has a chance to drop a raise boost power up. Isn't that neat? So let's see. Can I remove this fucking cube? Okay, I'm sorry I got angry there that one time. Okay, so let's see now.
Can we look at raise power.h after?
Yeah, let's do it after. There we go. So now I have the raise boost power up. So if I hit space, then it says from C++. So that's great. So using using Blueprint native events, we can override a function either from Blueprint or from C++. So now if a designer wants to make a new power up, they can do it entirely in Blueprint. Or if a programmer wants to make a power up, they can do it entirely from C++. So that's great. Isn't that neat?
Yeah, what could ever go wrong?
What could fucking possibly go wrong? Nothing.
Programmers and designers doing the same thing at the same time
Yes.
in different ways.
That's awesome. That's great. Because
No, it's not.
they can compare and see who's better.
I mean, programmer would win 100%, but still.
I don't think so. I don't think so, mister.
Bro, we are superior. Programmer overlords. Let's go.
I know, and actually, I've been making some anti-designer jokes, and I've been checking myself not to do that. Because designers are smart and beautiful, and they're awesome.
Can we look at raise power.h?
But what about level designers?
They're also beautiful.
Cringe.
What? Wait, why did I get shamed? What did I do?
Oh, you joked about wanting a recap, and I gave you a recap, and you made fun of me. That's what you did.
Oh, sorry.
So now,
yeah. Oh, that was
For everyone who's not in the Stockholm Discord, we have a poop brown role called shame that we assign to people whenever they do these nuts joke or something shameful. And the Emil hurt my ego, so.
Yeah, well, it was funny, so I take it.
But Thomas Wallin is excluded because he wants the poop wrong.
He asks to get poop rolled all the time.
He is a poop joke.
What did you say? I like to get pooped on? Did you say that?
I did not.
Oh.
No, I said
I thought you
maybe
got access
you're...
to my browser history there for a second. That's funny. That's jokes. All right, so we have a C++ version now. How nice. So let's make a. I was gonna say let's make a Koopa shell, but of course we're in doing boosting, so let's do boosting. I kind of forgot what we were doing there for a second. Kind of lost track of where I am. I'm thinking about the best way to do this. Why did I choose this one? This one is the worst one. So I'm thinking about the best way to do this. So we have to talk to the movement component, to the race car movement component to make it like go forward or something. So I'm actually gonna add some functions. I'm gonna do that. I'm gonna add some functions here. So before we had on power up activated, I'm actually gonna add a little bit more. I'm gonna add setup, which will be called whenever this power up is equipped. So we can use this to get the movement component. So I'll do void u raise power. I'll first implement the base function, like the base one. Remember, we'll have to do that when we make a blueprint native event. Of course, it won't do anything. So we'll just do nothing. It doesn't do anything. For the base version, that is. And I'll implement that in the boost power up. So that we can actually fetch the movement component. I'm gonna save that in as a private variable. I'll make it a U property just to make sure that nothing garbage related is shit. There's no way it should get garbage collected. But just to be sure, I'll make it a U property. So I'll save a view race car race movement component. Just what the hell did we call it? Race car movement component. That is what we called it. U race car movement component. It's not showing up for some reason, but whatever. There we go, and I forward clear that. There it is. So now to fetch this then. But how do we get which? So to get the component, we need to get the actor, because the way you get components, since components can only exist on actors, we have to fetch kind of the actor this power up is attached to or is owned by, so that we can then get the movement component from that actor. But there's no get owner, right? There's no get owner function like it would be in components. That just simply doesn't exist on U objects. That is something that gets added to components. However, we do have the outer. Remember that one? Remember when we spawned the... When we actually spawned the power-up, when we knew it, we provided the car as its outer. And you might have thought, oh, silly Emil, that's just a stupid thing he does. But no. It had a purpose. Because now we can fetch which actor actually owns us by getting the outer. Because the outer will be the car that owns the power-up. So we can use that outer to do something interesting. But I'm actually gonna make, like we could do this, like, you know, casts a actor, get the outer. But since this is such a like this will be used so much, I'm actually gonna make a function for this in the base class of power-up. So I'm actually gonna do that. Where is it? There it is. So in the base class, raise power up, I'm just gonna make a U function. I'll make it Rupin callable because why not? I'll do an A actor get owner. I'm just gonna return cast A actor. Excuse me, get owner. There we go. We could make this like get race car, or like cast this to a race car right away, because there's only a race car that would actually own a power up. But I like keeping it as an actor. Why not? Maybe I'll regret that, but. So now we have a way of getting which actor has equipped this power up. So now in the boost power up, we can do get owner. And then we can do find component by class. So this is the, get component in Unity, right? It's just like get any component by this type T. Or of this type T. So now we can type U, race car, movement components. And there we go. So now,
Do we need to include the race car movement component here?
yes, we do. Good catch, good sir.
Well, Ryder added it for me.
A fucking rider, dude. So we'll do FG. Fuck, what was it called? FG racing game, right? Player race car movement component. I believe that's where it was. That is what I must do. Nope. Get owner recursive on all control paths. Function will cause runtime stack overflow. Oh, whoops. Not get owner. I'm stupid. Get outer. There we go. Well, that's nice that it's caught that, actually. All right. So now let's just make it so we only pick up a. Let's just make it so we only pick up a boost. So I need to remove these. Delete. Delete. So we only see a race boost power up there. So now I have a boost. And of course we don't do anything, because we don't even call setup right now, so I don't even know why I tested this. I don't know what I'm doing. So we're gonna just make sure to call this setup. So I'll do this, actually. I will, on the car, I will make a function called equip power up. So instead of just setting this variable directly, I'm going to call this equip power up function. Where did I put it? So that now I can't call it that. I have to call it something else. I'll call it in power. New power up. Because that's the same name as the variable. So I'll do power up equals new power up. And power up setup. There we go. So now we actually call the setup function. So let's try it. Oh, whoops, I misspelled this. New power up with a big P. We don't call this function. Fuck. I keep running without doing my things, dude. So here, yeah. So here, instead of just setting this directly, I'm just gonna do car. Whoops. Car equip power up. There we go.
Could
So
you
if
show
you
the
just-
raise power up pickup CPP again? Thank you.
Yes.
Ah. Yum 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 yum. So now that we have the movement component in the boost power up, we get that from setup. When we activate, we can add some sort of boost to it then. So let's add some sort of boosting functionality to the movement component then. And I'm just gonna make it super simple. I'm just gonna do add force. How simple? Oh, let's make this constref. Have I talked about constref?
We've talked about it
Okay.
Don't remember.
a little bit.
Well, constref. So if a particular parameter in your function call is big, and I mean an f vector isn't that big, but essentially bigger than an integer or bigger than a float. It will have to copy it over, right? So when I call this function, let's say I just put something in right in zero vector, yeah, sure. When I call this function, it's gonna have to copy over this zero vector. So copy all of that into this force parameter, which takes time, right? It's not super cheap. So usually what you do is that you want to make it a reference. Because then it doesn't have to do any copying, but it still kind of acts like a normal. It still kind of acts like a normal parameter. You could make this a pointer as well, but then you have to change everything out to use like the arrow or the dereference notation, which is kind of annoying. So that's why usually you make it a reference. So then it doesn't have to copy. You can just like make a reference, which is much cheaper sometimes. Most of the time. However, if you make a reference, then you can change it. So if I change force, I will change whatever vector I passed into this function. And in the case of passing in something like 0 vector, that won't even work because 0 vector is a const variable. So I won't even be able to call this function. So that's why you make it const. So then I can't change force, which I usually could do with a reference. But it still will be passed in more cheaply than copying it over every time I call this function. So that's why you make big structs. If you take those as parameters, you make them const ref, usually. When it comes to stuff like ints and floats and whatever, like small things that fits just in one register on the CPU, don't worry about that. But yeah, if it's small things, then it's just cheaper to copy anyway. So that's why you don't do const ref for stuff like ints and floats. Because in the end, it's just cheaper to copy those than making a reference. So.
But if it's a const reference, it doesn't do the copying. What exactly does it do?
Well, it
Or
makes a
what?
reference.
Oh.
So it doesn't have to make some new memory just for this force parameter. Instead, you just reuse the memory of wherever the force came from.
Oh,
So-
right. It reuses the original.
Yeah, it reuses the original memory, so there's no need to copy anything. It's just like,
Yeah.
you can use the 0 vector while you're running. Like, it's fine. You can use that memory location just to read stuff. So that's why it's cheaper. Right, so we're gonna add some sort of add force here. Now, I know this is like kind of confusing. What's the difference between force and an impulse? I don't remember if I talked with you guys about this. I don't think I've talked about it. The difference between force and an impulse is that force happens over time. Something like gravity, or something like, yeah, in this case, the boost. So we will turn on the rocket behind us, and that pushes us forward over time. That would be a force. So it's something that's applied over time. Or something like, when we're gassing, when we're accelerating here, this would be a force. It's something that applies over time. An impulse, so let's add that as well. Whoops. An impulse is something that happens immediately for one frame. So something like an explosion. Like if you have an explosion in the game and you want stuff to start flying away from it, you would add an impulse. So that would be like the moment the explosion goes off, you add an impulse, and then that's it. That's the one impulse you add. So that's the difference between a force and an impulse. If you're planning on doing it over multiple frames, you probably want a force. If you're planning on doing it just one frame, like just a very quick, sudden kick, then you want to add impulse. And what's the difference? Force, since it's applied over time, uses delta time. So it will be velocity plus equals force times... Oh dear. We'll have to get delta time. I don't remember what it is. Get world delta. Get delta. Oh, there it is. Get delta cycles. A force is applied over time, which means we have to take delta time into account. While an impulse is just one frame, it's just one hard kick. So then we don't take delta time into account. And that's the difference implementation wise between a force and an impulse. So that might be when you're trying to give something a kick in Unreal, and you do something like add force, because you want to give it like an explosion kick or something, but you have to put in like a huge number to actually make it go anywhere. Then you probably want add impulse instead of add force. Because since it's timed by delta time, you have to actually give the number, make the number super big for it to actually do something. So then you probably want add impulse.
But the physics of the rigid body component, in its add force function, there's a bool to choose like axle change. I'm not sure exactly what that one is.
Axle change. What does that do? Hold on.
I think it says something about not caring about physics.
Oh.
Oh, okay. So it just ignores mass.
It ignores mass. Yes, exactly. So that would be kind of what we're doing right now, because we're not doing any sort of mass calculation for our car, right? We use like force, just add directly to velocity. And that's what axle change does. Right, so now we have our two physics functions for our car. So now we can start doing stuff here. So what we want to do is that we want to add some force then. Because when you turn, like in Mario, right? It's like if you hit power up, or sorry, use the mushroom, then you get a force for a few seconds and then it turns off, right? So we want to add force. So we'll say we want to add force, and we'll do get owner, get actor forward vector times 5,000. I don't know. Let's try that. So now if I pick up a race boost power up and I hit space, well, that was quite underwhelming. You might see that we get like a slight forward kick. But yeah, we have the problem now, right? That we want this to be a force that is applied over time. But on power up activated only runs once. It runs when we hit spacebar. So where do we put the code to actually like make it run longer?
Tick?
What?
Tick, maybe?
Yeah, so that's the thing, right? We need some sort of ticking. Like I said before, right? U objects don't have any type of tick. Ticking is not part of the U object at all. Like it's sort of added onto it by the actor and the component so that they have ticks. But U objects by themselves don't have tick. So we're gonna have to add it ourselves. So I'll just add tick active. And the reason I'm calling it tick active and not like tick is that I only want this to be called while the power up is activated.
But wasn't there? We used the tick component
Yep.
thing before, but that won't work here.
No, that only exists on components, and this is just inheriting from U object.
Oh, okay, I see.
Yeah, this is not a component; it's a U object. So we're gonna add this tick active, and that's only gonna be called while the component. While the power up is actually activated. So we won't be able to check tick all the time, only when we're activated. So is implement the base version of that does nothing. Actually, I'll make this same line. There we go. Very interesting CPP file. Use functions with nothing attached to it. And this is very common, right, for single layer inheritance. Remember that we wanted to avoid supercalls. Remember that? So here I'm sort of putting that to the test, right? I'm just making sure that all the base versions of every function don't have any functionality because I want to avoid supercalls. So now we have a tick active. So let's implement that then in the boost. Tick active implementation. Right. Implementation. There we go. So now I can put this add force not in on power up activated, but rather on tick active. If any of you goes to haste lights, you will recognize these functions. I'm kind of taking them from a very core system we have at haste light called capabilities. I'm sort of taking a little bit of inspiration from that system because I think it's very good. So if you guys go to haste light and you're ready, then you're prepared because you know. Okay. So let's call this then. So holy shit, we've been gone so long and we haven't taken a break. I'm so sorry. Let's take a 10-minute break. So I'll see you guys back 11:20. Hello.
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 What was that crazy laughing we heard, Mr. Evil Scientist?
Oh yeah, I didn't mute my microphone. I was looking at memes. And one was funny. All right then. All right then. Let's go then. So I will do. I know what I must do. So we'll do a bool here. Power up activated. So when I hit spacebar, I will set this as true. Call on power up activated. And while it is true, I will call tick active. And that's it. How simple.
Why the B prefix?
Because that's Unreal, baby. Bools are usually prefixed with a B. I don't know why.
How about the garbage collection on the bool?
Well, the bool can't be garbage collected, so I think we're fine. Usually garbage collection is only for U objects. So,
I see.
right. So, yeah. So on handle activate power up, we'll set, if the power up is not null, then we'll set B power up activated to true. And then on tick, I will check if we have a power up, so if power up is not null pointer, and we're activated, then I will call power up tick active. Maybe I should have added a delta time there.
Which file are you working in?
Racecard.cpp. Oh, Jesus. Jesus Christ. Do you guys believe in Jesus? Papa bless.
We don't want tick active implementation.
No. So when we're calling these blueprint native events, we want to call like the function that the U function thing. And then whatever tick active gets defined as by Unreal will call either the blueprint version or the implementation version, like the underscore implementation, based on, you know, what's overridden where. So when we're calling, we always want to call this tick active and not tick active underscore implementation. Right.
And where did you put the B power up activated boo?
On the car.
Okay.
So let's see what happens. Oops. Oh, whoops. This override shouldn't be here. Override should only be in the header. Oh. Let's see. So we have a problem with raise power up tick active. It's not implemented for some reason. Well, wait, already defined. What have I done? Oh, whoops. I did tick active here. Of course, this is supposed to be implementation. There we go. So I implemented the wrong function. I implemented the U function version, like the native event version. But of course, that's implemented by Unreal, so we don't implement this. We only implement the underscore implementation. La 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 la. Alright, so I pick up the power up, and if I hit space, then okay, so it works. It was quite extreme, I would say. So maybe we have to tweak that a little bit, but seems to work.
I don't know. It looks kind of fine to me.
Yeah, it looks normal. It looks like Mario Kart. Oh, I'm stuck. Oh, there we go. I can't even brake. Like my braking is not strong enough. Okay, so we need to do some tweaks there. But it worked. So now when I activate the power up, it stays active and the tick is called. So we can have power ups that last for a long time. And in fact, now they last for infinity time. Oops, okay, I'm flying now. I hit like the corner of that of the ground, so I got lifted into the air a little bit. So yeah, clearly our movement is not really designed to handle this kind of speed. Right. Of course, we don't want power up to stay active forever. We want them to be able to deactivate at some point. So let's do that then. So what I will do, I'll make another blueprint native event, and I'll call this should deactivate. And that will return a bool. And what this will do is that the car will call this should deactivate when the power up is active, and just ask it like, "Hey, are you done? Are you done?" And if this returns true, then it will deactivate the power up. So if it's just one frame, then it might, activate and just immediately return true for should deactivate. Or in our case of the boost, maybe we do like, it activates and then it has a timer for like 2 seconds or something. And then after 2 seconds, it returns true and should deactivate, meaning that the boost power up deactivates. So let's implement this. La 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 la. Oh god. Of course, yeah, we have to give it something. So I'll return true as default. So the base version, since it is a function returning a bool, we have to return something in the base version. So I will just return true, which is like, kind of the safest behavior, right? If you don't implement should deactivate in your derivative, then it will just be like, you'll just deactivate on the next frame. You deactivate as fast as you can. So that will be the default implementation. And if you want a timer or something, or whatever, then you can override this and add whatever logic you want to it. Whoops. So now that we have a deactivate function, I will head over into our race car. Race car. A race car. So I will do. So if we're activated, then tick. And after the tick active, I will check if power up should deactivate, then be power up activated is false. So after I've ticked, I check, okay, you've ticked now. Are you happy? Do you want to deactivate? And if they say, yes, I want to deactivate, Papa, then we deactivate. So then we set activated to false. Thomas, yes, Papa. Making code, no, Papa. Telling lies. God, my washing machine is just going absolutely buck wild. Hold on, give me a second.
Hey, that's like that one awesome game from our game project with the laundry machine that
What, really?
destroys everything. Really cool game.
That reminds me of the David Firth like Burnt Face Man episode where they play like the washing machine simulator. Any Burnt Face Man fans out there? Anyone?
Say what now?
I guess it was before your time.
Birdman?
Burnt Face Man. It's a superhero who has like a burnt face.
I'm old, but I missed it.
Right, so now we have the same behavior again, where if I hit space, we just immediately, like, we get a little bit of a kick, like we tick once, but then immediately after we've ticked, we just deactivate again. So that's good, because we didn't implement.
What about using a timer to just have like 1 second of boost or something?
Yeah, so that's what we want to do, right? So right now we're not implementing this should deactivate, it's just we're using the base version that just returns true. So of course in our boost, since we want that to be active more than just 1 frame, we want to override this. So I'm gonna override it, should deactivate. There we go. And we want to return true or false based on some timer. So I'm gonna make a float here. It's gonna be boost time. And on activated, I will set that to... How long is usually a boost? 2 seconds? I'll do 2 seconds. And then in tick, I'm just gonna decrement that. So we can do minus equals... I should have delta time here. Crappa. We'll just add it. And you of course have to add that to the base version as well. Sorry, that's my bad. I just went in and added delta time as a parameter to all these tick active functions. So in the base class, I added delta time. And then in the boost, I also added it to the tick here. So now we can do boost time minus equals delta time. Super simple timer. And then we'll just return boost time is less or equal to 0. So that's gonna be our deactivation condition. We deactivate when boost time reaches 0. So then we'll be active for 2 seconds.
Emil,
Yes.
do we need to like also reset, like, you know, we're increasing the force. Do we need to reset it back, or does it reset on its own?
Yeah, this add force, it will only be valid as long as we call this function. So the moment we stop calling this add force function, there won't be any force anymore.
Oh, okay.
Where did we add delta time?
I added it in the tick active. So I added it in tick active here in the boost. And I also added it in the power up base. So here in the power up base, I just added delta time to the function here.
Could you show raise boost power up again?
Raise boost power up. Raise boost power up. Right. So let's start to compile. See what happens. Right, so we have some problems. So here in race car, when I'm calling tick active, of course I have to provide a delta time now, because we changed the tick active function. So let's provide delta time here. Easy. Easiest fix of my life. So let's pick up a boost. Hello. There we go. And now, if I hit spacebar, then boost. And after 2 seconds, it went away. So boost. And then 2 seconds, it went away. I'm gonna decrease the boost, alright? I know that's very controversial, but I'm gonna decrease it. It's a little bit too strong. So let's go and power up and let's change this to maybe 1,000 instead. Just restart. Because it's kind of hard to see what's going on when I'm just crashing into things, flying away. Okay, let's try it. So grab a boost. And then boost. And then it stops. Boost. And then it stops. Boost. Cool. So now we can have power-ups that are active for longer than just one frame. So they can sort of stick around a little bit. Isn't that nice? Let's actually, because it's kind of boring right now, how you kind of like, when you activate it, it doesn't really feel so juicy. It's kind of like, yeah, you go faster, but it kind of like, you kind of slowly speed up to going fast. So since we added the, you know, the add impulse function to the car, let's actually do this. Let's unactivate it. I'm actually gonna add a impulse to the movement components. Times 1,000. I don't know. I'm just totally guessing on these numbers. So we're gonna give the car an initial little kick. When you actually hit spacebar, I will give the car a little kick, just to kind of get it like a little bit more juice when you actually activate the boost. And then the remaining time, I give you a force for 2 seconds. So now we have two parts. We have the kick and we have the boost. And hopefully that will make things a little bit more juicy. Yeah, I'm a game designer, by the way. Hello. So if let's just make let's just make this fucking level a little bit bigger. There we go. It's so hard to fucking navigate. Okay, so now if I boost, there we go. I get a little kick. Oh god, I actually go so fast. So I give the car a little kick, and then we get a boost.
Should the boost work in reverse though? Is the question. Shouldn't it just boost you like forward?
It does only boost me forward. So if I go backwards, then I'm working against the impulse and the force here.
Oh, okay. Yeah.
Just for checking, which is the front?
The box is the front. So it's kind of like a pickup truck.
Damn, that's weird for me.
Yeah,
I thought it was the other way around.
Yeah,
this entire time. I thought that was the roof on the like old school car. Something.
Oh no. So clearly our car needs a bit of work, because when you're going fast, you like turn on a dime. You see that? So probably at some point we're gonna have to do some back surgery to our car a little bit. But let's not do that now. The boost works, and that's all I care about. So when I hit space, I go fast, and then I slow down after the boost goes away. So go fast, and then slow down. Cool. So that works. Now let's just do a little bit of fixing up before we take lunch. Some few easy bugs that we can kind of squash. First of all, of course, we can use a power-up infinitely. Like, I don't have to pick up another power-up. I can just keep boosting forever. I can also activate it as many times as I want. You see that? So if I pick up a boost,
Not a bug, a feature.
yeah, it's a feature. So when I have a boost, I can use mash space and activate it as many times as I want. Which of course also is not intended. And the third one is that I don't want to be able to pick up something else when I have a power-up equipped. So if I have boost equipped, I don't want to be able to pick up something else. So I'll just go through them. So I have to use the power-up to actually pick up something else.
We do have the list of power-ups though,
Yeah,
so we could queue them.
queue them.
Like use them one after another.
Oh, yeah, we could do that. But I think it's easier just to do like Mario Kart rules. But yeah, we could also do some sort of queue system like you said. Maybe after, maybe it's later on. I've been working on the railroad all the ding dang day. I'm in a singing mood today. You guys are just gonna have to deal with it.
Can we look at the raise power up CPP and H? I'm having a very stupid error right now.
Stupid error. What is this? Quick actions. What? Ah. Oh.
It doesn't work for some reason. I'm getting class U raise power up has no memory on power up activate _ implementation, even though it's the exact same.
Show me. Show me. Show you.
It must be something very simple I'm missing right now.
Well, I mean, that's an IntelliSense error, first of all. So I
Yeah.
would just build.
Oh yeah, it could just be something else then.
Yeah, check the out.
Right.
Yeah, do in the build plus IntelliSense, turn off. There's a drop down there. Yeah, do only build. Let's see. On power active. Okay, hold on. Go to the first one. The first error. Okay, and then go to raise powerup.h.
Don't tell me it's because of the comment.
Shouldn't
be.
be.
I'll try building.
Yeah, try without the comment, I guess.
I'll be fucking pissed if it's because of a goddamn comment. Okay, no. Boost time is identifier.
Do you in raise power up? You do all of the good citizen things, right? You do generated body and yeah, you do. Scroll down in the erase power up. Oh yeah, not H. Scroll up.
Okay, it is the exact same. Why is it not working?
How
But
does the includes look in the header at the top?
raise power up.h.
Yeah, looks good to me. Scroll down again.
Yeah,
Let me see. I'm guessing there's a spelling error. No, I can't see.
I got a feeling it could also be because of this. Maybe it's like one error that just causes the entire program to have
No,
a
I don't think so.
seizure.
I don't think so.
Try to comment out the on power up active function and see if it works then.
No. I don't think that's gonna do anything.
And then, yeah, the same is CPP. If it doesn't do anything, then at least we know that, yeah, it's just the IntelliSense battery.
Well, it's not IntelliSense, it's build. So there are builds.
Yeah, like that.
Well, because we're calling on power up activate a bunch of
Wait.
times.
Yeah, that's not gonna help.
The top arrow that talks about override function. Maybe it's something like that.
No,
One
it's
of the
saying override
overrides.
because for some reason that function is not generated, the implementation function.
Hold on. I did
When it's boost time undeclared identifier, where do you create boost time?
boost time. I create that in here. Wait a minute.
It's in private. Maybe it's something like
Well,
that.
I mean,
Right.
the reason that's failing is because you're calling it from a function that isn't overridden. So that's why that's erroring.
Huh?
In the end, all of the other errors are just a symptom of on power up activate implementation not being there for some reason.
Yeah, like if there was some way I got to the generated file thing.
Yeah.
And I think that one did show up.
Can you do that? Can you right click on power up activate, go to definition declaration? Nope.
And there was some way I got there actually.
My guess is that it's not correctly spelled in one of the.
Yeah.
Just try to copy the function's name in the CPP, and then paste it in the header, just to make sure it has the same name.
Yeah, it should be the same, right?
All right, try this. Could you go to in Explorer, like in Windows Explorer? Can you go to the project file? Yeah. Okay. Cool. Go to intermediate, build, Win64, UE4 editor, Inc. Yeah, FG Racing Game, and then open up race power up generated.h. Ja, precis. Careful, scroll up.
This is very scary territory.
Yeah, scroll up. Scroll up.
It's not there.
Yeah, it's not there. I'm wondering if that just went out.
What about generating the files again then?
Yeah, I'm thinking that might have went out in the wash, perhaps.
True. So I'll just
nuke intermediate and pet play.
Yeah. Then generate the new
Yeah,
files.
then generate exactly. It will be
Also
weird. I
wonder-
think there's something else I'm missing here, but can't put my finger on it.
That's one very stupid error if this fixes it.
Yeah, I would be surprised if this fixes it. I think there's something else. Oh, you have to set the FG Racing game as starter project. Kind of weird that it doesn't do that.
This whole engine is weird.
Hey, now you watch your mouths, mister.
Yeah, but like it's a lot of quality of life features that's just gone. For example, IntelliSense not
Yeah.
being as good as it used to be when you just use an ordinary C++.
Let's just write everything in Notepad to get the Dark Souls experience.
That's good shit.
No.
Could you check your build output instead of the error list?
Sure, where do I go for that? Oh, yeah, it doesn't like that.
Yeah.
Far.
It's you have it like super small at the bottom for some reason.
Beautiful, there's nothing there. Build order. I don't know how to decipher this.
Yeah, just scroll up.
Make this bigger. Damn it.
Scroll up.
On Power Act is not member of U-Race Power Up. This is probably just like a single letter that's off. It's
Scroll
messing
up.
all with it.
Could be a spelling error somewhere.
Yeah, it could just be like one letter.
Yeah.
Okay. Okay, let's check the header and the CPP again. Am I stupid here? I feel like I'm missing something. Could you make them? Could you make a horizontal split instead of a vertical split so we can see the whole file at once? Yeah, just close everything. I think.
Shit. I can. Right. I could like actually.
What are you doing? Close them. Oh, okay.
Yeah.
Oh.
Wow.
Wow.
Yeah. Cool. So, right.
So go to raise power up and then. Oh, you have it commented out, Lemao.
I swear I fixed that. Damn it.
You commented out the comment now as well, so.
Okay. And I did. It's yeah. Give one more try. Maybe it's. No.
Okay,
Alpha, can you scroll up to the top of the header file too?
Cannot even open it.
That's just
No.
again. Tell it. Don't trust the red squigglies.
All right. There is a truth to that. We should just use Notepad.
Yeah,
Same
that's
experience,
why,
really.
That's why I use. Sublime.
Let me look here in the intermediates again.
Yeah, there it is.
Yeah, it's.
Could you like copy paste that into the? Could you like copy paste that into the CPP file? Did it change?
No, I don't think, but
Try.
maybe the. For insanity measure check. It doesn't like it. On power is not a member of what? Yeah, now we're in whatever this thing is. Exit on power up activate.
What the hell has gone wrong here? Okay, let's do this. Could you send the project to me and I can take a look at it? Just send these 2 files to me.
Which 2 files? The raise power up?
Yeah, the raise power up. And have a look over lunch and see what the fuck is going on there. That's a super weird bug you got there. I'm wondering if it's an Unreal bug or not. Or if it's something I missed.
Which ones?
Just raise power up.h and CPP.
Raise power up.h.
And CPP.
And yeah.
Yep.
How do I send them to you?
Yeah, just DM me on them. All right, let's take lunch. So I'll see you guys back 13:00.
Yep. See you in an hour.
Yeah. Okay. See ya. Bye bye.